these steps down. Number 1, pull out a GCF if there is one. This is the number 1 thing you should always do. The first thing you should do is look at your polynomial, see if it has greatest common factor. If it does, pull it out. Then number 2, factor using either the box or the grouping method. Number 3, yay, you're done. Okay, so we have 3 examples, y'all. It's a short, quick video. We're going to do 3 examples. Here's the first one. 4d squared minus 28d plus 40. Is there a greatest common factor? There is. It's 4. Factor out the GCF. So if I factor out of 4, what is left when I factor out the 4 is d squared minus 7d plus 10. I just removed the 4 and wrote down what was left once I pulled the 4 out. Now I'm going to factor what's in parentheses, and I'm going to do it using the box method. Okay, so I'm going to draw my lovely little x. 1 times 10 is 10. D squared goes here. Negative 7d goes here. I need factors of 10 that will add up to make negative 7. Can anybody think of 2? 5 and 2. 5 plus 2, however, makes positive 7. How do I make it make negative 7? Negative 5 and negative 2. So these are the 2 numbers I'm going to use to break this up to factor. The 4 remains because it is one of my factors. But now this d squared business becomes d squared. Instead of minus 7d, I'm going to put negative 5 minus 2. So I have negative 5d minus 2d because this makes this. Then plus 10. No, it's negative 7d. Okay. Now, I'm going to use the box to factor this, and the reason I'm going to use the box method and not the grouping method is because of this minus sign in the middle. I have a minus sign in the middle. I hate the grouping method when there's a minus sign in the middle. So I'm going to do the box method. So I have d squared minus 5d minus 2d plus 10. Greatest common factor for the top row is d. For the bottom row, it's going to be a negative 2, and the reason it's negative is because the first number in the box was negative. Greatest common factor for this column is just d. And for the second column is going to be negative 5 for the same reason. The first number in the column was negative. So my total factorization for this problem is going to be 4, because that was the GCF, then d minus 2, and d minus 5. Okay, the next example, you can see I scratched out the original. This is the one I want you to write out, is the negative 15x squared minus 3x plus 12. When I do the factor, when I look for a GCF for this one, I am going to factor out a negative GCF because the very first number, the leading coefficient in this polynomial, is negative, and I don't want to factor with a negative. So I'm going to factor out a negative GCF. So my GCF for 15, 3, and 12 is 3, but it's going to be a negative 3 because I want that negative to go away. So that's going to change all my signs when I write them down in here for the polynomial that is left over. Negative 3 times 5 gives me 15, so I have 5x squared. If I want to have a negative here, like this in my answer, I'm going to have a plus sign here. Negative 3 times 1x gives me negative 3x. And then if I want this to be positive, a negative and a negative makes a positive, so this is going to have to be negative 3 times negative 4 makes positive 12. So now I'm going to factor this the same way I factored the other one. So negative 3 is going to remain part of my answer, but then I have to factor this. So I'm going to have to do 5 times negative 4 first. Well, 5 times negative 4 makes negative 20. And so I have negative negative 20 x squared, and then the number in the middle is just 1x. And so I need factors of negative 20 that are going to add up to make positive 1. Well, 5 times 4 makes 20, and if I do 5x and negative 4x, they will add up and make a positive 1. So I'm going to do the box method again, just like I did before. So now I have 5x squared, and then I'm going to do 5x and negative 4x because that's what it's split into. And then this negative 4 is what goes here, not the 1 in my square or in my x, the negative 4 that was in my actual polynomial. So now I'll factor. Greatest common factor here is a 5. Greatest common factor here, since they're both negative, happens to be there's an x there, it's 5x. Happens to be negative 4. Greatest common factor here is just x, and here is 1. So the rest of my factors, one of them is negative 3, the other one is 5x minus 4, and then x plus 1. The thing to remember is you never ever want to factor a polynomial if the leading coefficient is a negative. If it happens to be a negative, please factor out the negative, then factor what is left. So let's do one last example. This one's a little bit shorter. So I have 3x to the 4th minus 12x squared y squared. Well, there is a greatest common factor. Between 3 and 4 is going to be 3. And they also have an x squared in common. So when I factor out that 3x squared, what I have left here is an x squared, so that I get my x to the 4th. And then here I get a 4y squared. Now this can be factored, and we have not talked about special products yet, but this one's really simple because it's what we call a difference of two squares. We'll talk about this some more in a couple days, but a difference of two squares means just that. It is a difference, so it's a subtraction problem of two perfect squares. 1 is a perfect square because 1 times 1 makes 1, and then x squared, clearly it's a perfect square because it's in the name. Then 4 is also a perfect square because 2 times 2 makes 4, and then of course y squared, it's in the name again. So to factor a difference of two squares, you are going to take the square root of the two terms, and your two factors, one will be plus and one will be minus. So the square root of 1x squared is 1x because 1 times 1 is 1 and x times x is x squared. The square root of 4y squared happens to be 2y because 2 times 2 is 4 and y times y is y squared. Do not forget the 3x squared that you pulled out as a GCF. You are done. It is now factored. We will practice this some more tomorrow as an activity in class. Number 1 rule, please remember to do this at the very beginning every single time. Look for a greatest common factor and factor it out if it's there. Because if you don't, your factor is not going to work and you're going to look at me and go, I don't understand why I didn't get it right. So number 1, please always make sure, factor out a GCF first. And if you have a negative leading coefficient, make that disappear. I will see y'all tomorrow. Have a good day.